One thing is true, things change, and as data people, we need to deal with it. Let me show you what I mean. Suppose I have a table which gives me information about people. It might contain information like ID, their name, and their address. For example, a record with ID of 1 talks about a person named Harry who lives at 4 Privet Drive. That's great. One day, though, Harry moves from this address to another address. Not a problem. I can update that record in the database so that we still have the same ID and the same name, but the address is the current address. Great. But what's not so great is I no longer have information of where this person used to live. I lost that piece of history. One way of updating a table while still retaining history is the use of slowly changing dimension tables, or SCDs. If that sounds like gobbledygook, check out this video somewhere up there, and then come back here. You'll be fine. The basic idea is this. I need to maintain different versions of each row. And one way of doing that is by adding two columns, the start date and the end date. These columns give windows of time for when each version of the record is active. For example, this first row, where Harry lives at 4 Privet Drive, that's active between 1981 and 1996. But on this date in 1996, something happens. Harry moves to another address. This second record is active on the same date that the first record became inactive. It's still the same ID, the same name, only the address is different. This type of table is called a slowly changing dimension type 2 table, and they're very common, but they're a pain to manage. Think about it. Every time something changes in the real world, I have to dig through my table, find the previous record, make it inactive by updating the end date, and then enter a new record, making sure that the start date is the same as the previous record's end date. This process is very difficult to get right, but fear not. dbt has a solution. In the data transformation tool, dbt, there's something called snapshots. Snapshots are dbt's way of implementing type 2 slowly changing dimensions over mutable source tables. Today we'll talk about what a dbt snapshot is and how to implement it into a project. So let's begin. First, what is a dbt snapshot and what does it mean to implement anything over a mutable source table? Well, the idea is this. Suppose I have a table that I want to track changes in. I give information about this table to dbt, and dbt will watch that table like a hawk and track any changes in a second table called the snapshot table. Anytime something changes in that first table, dbt will update the snapshot using type 2 SCD logic. That's a lot of theory. Let's just try it out. I'll create a source table and then show you how dbt runs snapshots against that source table. For this, I'll use Snowflake. Here's a Snowflake environment. It's pretty empty, but we're about to fill it up. Here in Snowflake, I have a database called demo and one schema called core. In the core schema, there's nothing in there. So let's make our source table. Let's make our source table in this core schema. Back in the terminal, I have a couple of SQL scripts I'm going to run, and I'll run them in the Snowflake CLI. To start, I'll make sure the warehouse is running, and I'll tell the session to use our database of demo and our schema of core. Now I'll create a table. The name of the table is called students. It has 4 columns, ID, a couple of information about the students like name and house, and this last column, last updated, is a timestamp indicating when each row was last updated. I'll run this, and now I should have an empty table. I'll fill the table with a couple of records. The first record will be ID 1, Harry, who's in Gryffindor, and a second record is similar to that. And now that I have records in the table, I should be able to query against it. And I can see that, yes, I do have data in the table. Hopping back to the UI and refreshing, we can see that the table does in fact exist. Great, I have a source table. Now I'll make a snapshot. The modern way of making snapshots is by using a YAML file in the dbt project. Here I have a dbt project, and it's a standard project structure that you might be familiar with if you've used dbt before. I have my dbt project file here, models go in models, seeds going seeds, and unsurprisingly, snapshots are recommended to go in the snapshots folder. I've already created the snapshot configuration in this file. Let me show you what it looks like. Snapshots are listed as a YAML array under this snapshots key. In this case, I just have one snapshot listed. Here's some of the info I need to give dbt as it tries to track that source table. First, I need a name. This is the name of the second table, that snapshot table, which in this case I'll call students underscore snapshot. Second, I need to tell dbt what table to keep track of. That's done by entering something for the relation key. For this relation, I'm using source core students. And that probably doesn't make sense because you haven't seen my sources YAML. So let me pull that up. I have one source given the name of core, and within that core source, I have one table called students. So in dbtc's source core students, it knows that I'm targeting the table in the database of demo schema of core and with the table name of students. After that, there's a little bit more configuration to give the snapshot. First, I tell dbt what database and schema this snapshot should live in. I'll use the same database but a different schema to isolate my snapshot. And then I start wondering, hey, how is it that dbt is able to match up rows from the original source table with this snapshot table? That's done by using something called a unique key. Think of it as the primary key of your table that uniquely identifies a row. It could be one column or it could be a list of columns. In my table, I have a column called ID, which serves as the unique key or as the primary key. So in the config block, I enter unique key as ID. And then I wonder, okay, after dbt can match up rows from the source to the snapshot, how does it know if the snapshot record is stale or out of date with the source? Well, that's for me to decide. There are two ways or two strategies for telling dbt if a change has happened in the source table. Back in the dbt docs, we can look at those two strategies here. They are timestamp and checked. Timestamp is easier and thus the recommended approach. It goes like this. Ideally, your source table has some kind of column that tells you when each row in the table has been updated. And if we tell dbt what that timestamp column is, then every time we run the dbt snapshot command, dbt will look at the updated that column in that table. And if it's more recent than the last time that the snapshot has run, it will invalidate the old record in our snapshot and create a new one. But if all the timestamps in the source table are before the last time a snapshot was run, then dbt doesn't take any action. In my table, I have a column that does this. If I go back to my Snowflake environment, I see that this table has a last updated column, and the value of this should update anytime the row changes. So I'm going to use timestamp for my snapshot. I declare that by entering timestamp for the key of strategy, and because I'm using this strategy, I also need to tell dbt the name of the column that represents when the row is updated. All right, now before we run the snapshot, let's quickly talk about the second strategy. The second strategy is called check, and it's useful when I don't have a column in my table that tells me when the row was updated. Here's how it works. I give dbt a list of columns to keep track of in the source table. And every time dbt snapshot runs, it will compare the current records in the source table with the historical records in the snapshot. If any of those columns have changed, dbt will invalidate the old record in the snapshot and then record a new one. But if those columns are perfectly identical, then dbt will not take any action. The check strategy works, but it can be fragile, particularly due to schema evolution. I might make a snapshot with the check strategy with a list of columns, but maybe one day I add a new column to the table and I want to include that in the dbt snapshot. That means I have to change both the source table and my configuration for the snapshot. Or the opposite might happen. I might remove a column that happens to be in the list of columns that are checked. And if that happens, the snapshot would break if I did not update the configuration and rebuild the snapshot. Because of these headaches with the check strategy, the timestamp strategy is recommended. All right, enough talk. Let's finally make that snapshot table. I'll go back to the dbt project, and creating a snapshot is as simple as running the command dbt Snapshot. This command will search for all snapshots in the dbt project. Remember, there's only one. And the first time it runs, dbt will recognize the snapshot table does not exist. So it will look at the source table, capture all the rows, and create that snapshot table. The results show that it was successful, and this 2 represents 2 records that have been processed. Back in the Snowflake CLI, I'll query both the source table and the snapshot to see what the contents look like. Okay, at the top, I have the original table in the core schema, and the 2 records are still there. And this is the snapshot table in the snapshot schema. Notice that it still has the same 4 columns, ID, name, house, and last updated with 2 rows, but there are additional meta columns that are added here. Let's look at these. Starting on the right, we have dbt valid from and dbt valid to. These are the start and end date columns that are common in slowly changing dimension type 2 tables. Since I just ran the snapshot, the valid from date is right now, and the valid to date is null. Well, it shows as none because the CLI is built with Python and null renders as none. But we can verify that it's truly null by going back to the UI, and if I refresh this, we should see that new schema with that new table representing the snapshot. And going over to the data preview and scrolling over, we see that dbt valid to is in fact null. Great. We also have another column called dbt updated at. This is a column that represents when the row was updated in the source table. And the last column is called dbt SCD ID. This is something that's used internally by dbt to determine which rows need to be updated every time a snapshot is run. It's a concatenation of the unique key, which for this table is the ID, and the timestamp, which in this case is given by dbt updated at. The value looks a little funny because it's a hash of this concatenation. I don't worry too much about SCD ID, that's used internally by dbt. For day-to-day use, the valid from and valid to date are what's most important. All right, the snapshot now exists. Now, let's see what happens if the original source table is modified. How does the snapshot react? I'll do three things. Add a new record, I will modify an existing record, and I may even delete a record. And after each change, I'll rerun dbt snapshot to see how the snapshot table reacts. First, let's add a record. We'll add our favorite witch to the table, Hermione, who's in the House of Gryffindor. One row has been added, and I'll go back to the dbt project and rerun the snapshot command. The second time that snapshot runs, it'll recognize, okay, there's already a snapshot table, and it will look in the source table to see if there are any records with timestamps that are later or after the last time the snapshot was run. It seems like it's found one because we see that it successfully processed one new row, which hopefully is Hermione's row. We can verify that by going back and querying both tables, the source and the snapshot again. We can see that Hermione did make it into the source table in core, and it looks like she also made it into the snapshot. Note that this time, Hermione's valid from date is a little bit later. It's at 8:41, a little bit later than the original records that were added. Cool. Now let's make things interesting. I'm going to modify a row in the source table. I'll target this row and just do something simple like making the name all uppercase. So let me go back to my queries and I'll modify the row by running this command. Since Harry has an ID of 1, I'll run an update command where I'm targeting ID of 1. I'll set the name to all uppercase Harry, and because I changed the row, I'll also modify the last updated column to be the current timestamp. One row has been updated, back to dbt, and I'll run dbt snapshot again. This time dbt should recognize that a change has been made to a row that's already in the snapshot, and it should run through the type 2 SCD process. Let's see. One row has been processed. Back in the CLI, we'll query the same two tables to look at their state. And oh, look at this. The first row now does have uppercase Harry with an updated timestamp. And check this out. There are two versions of Harry now. The first one has now been invalidated. It has a value for dbt valid to that was just a couple of seconds ago. And there's this second version, same ID, same house, just a different name, that became active at the exact same time when the previous record became inactive. And the second table is current because we can see that it has a null valid to date. This is a fully functioning type 2 SCD table. Amazing. All right, one more change. We've added a record, we've modified a record. Let's now delete a record. I'm going to delete this record, Draco of Slytherin with ID of 2. Go back to my queries, and I'll run a delete from command. Row has been deleted. Back to the dbt project, run dbt snapshot one more time, and you might think, okay, dbt is going to do something to invalidate that record in the snapshot, but 0 rows have been processed, which looks a little suspicious. Let's look at those two tables again. As expected, Draco is no longer in the source table. Draco does appear in the snapshot table, which is okay. We don't want to remove any historical records, but the valid to date is still set to null. This makes it look like the record is still active in the snapshot. And that's by design. When I delete records from a source table, a decision has to be made on how that action is going to be reflected in the type 2 table. By default, dbt won't do anything for you. You have to opt in to hard deletes. Let's go back to the documents to walk through that. I'll go down to the delete section. And what you'll find is that there's another configuration parameter called hard deletes that handles deleted rows from the source. There are 3 options for this parameter. The default, which is what I have, is ignore, meaning if a record is deleted from the source table, dbt ignores it and doesn't do anything in the snapshot table. What I want to have is this invalidate option. When hard deletes is set to invalidate, any deleted records are invalidated in the snapshot by replacing that null valid to date with the current timestamp. So let's do that. I'll go back to my dbt project and I'll add that extra piece of configuration. It's called hard deletes, and I can spell, and I'll set that to invalidate. Save and close, and now let's rerun the dbt snapshot command. That's done, and it's already looking more promising. I can see that 1 row is successfully processed. Back in the CLI, I'll recheck the snapshot table. Draco's still there, but this time he does have a non-null value for the valid to, meaning that this record has been invalidated. I can clearly see that it's no longer active. Nice. Now there is that third option for the hard deletes parameter. That is called new record. New record acts a little bit like invalidate in that it will update the dbt valid to column, but it will explicitly recognize a deleted row by creating a new row and also creating a new column, a Boolean column called dbt is deleted. You can check this out if you're interested in that approach. All right, hope you can see the power of dbt snapshots. They make the management of SCDs, type 2 SCDs, much more simple. Without snapshots, I have to write custom code to invalidate historical records, add new records, and make sure that the dates between historical and new records are perfectly in sync. That's too much work, so just use dbt snapshots. I've just covered the basics of dbt snapshot configuration. There's more that can be changed to suit your needs. For example, I personally don't like it that when a record is active in dbt snapshots, the default valid to is null, or none as you see it here. I like having that high end date of 9,999 because then I can use my SQL between statement to query for active records. Well, guess what? I can make that happen in snapshots. Here I can set a configuration called dbt valid to current to be anything other than null. So here I can set a future date like 9,999. I also don't like the names of these meta columns, dbt valid from, dbt valid to. It's too much dbt. I'd rather have simple column names like start date and end date. I can configure that in my YAML file. Let me go back to the dbt docs and show you. I believe there's an example here. Here we go. So here in our config block, there's this key called snapshot metadata columns, and this is a way to remap the default column names that dbt has for the meta columns to something else. So if I want start date and end date, I would just add this to my config block. Anyway, that's all for now. I think snapshots are amazing. They make my life a lot easier as a data engineer, and I hope this helps you. Until next time, happy coding.